Okay, so here are the examples for tomorrow's quiz, and if you watched the first video, this one hopefully will be improved because I made some mistakes on it. So first of all, let's start on the basic level. If you don't have your antiderivatives memorized, that's okay, although it is good to have them memorized, but they are in the formula packet, which you will get during the quiz. So here are all of our antiderivatives that we're going to be using. And one thing you'll notice that's not on here is how do you do U substitution. So that's the process that you do need to know how to do. But otherwise, the basic derivatives are all here. So that'll get us through level 1. So level 1, I just need to add 1 to my exponent. So I get x to the 4th, and then multiply by the reciprocal of that new exponent. And since it's an indefinite integral, make sure you do the plus c. So there is my antiderivative for letter A. Letter B, sine x, the antiderivative of sine is negative cosine. So be careful on that. The derivative of sine is cosine, but the antiderivative of sine is negative cosine. So this is going to become negative cosine x plus c. And that's it for the antiderivative. E to the x is still e to the x. And 1 over x is natural log of x. Okay, again, these are all on the formula packet, your basic derivatives. So hopefully everybody can do that. All right, next one. We need to evaluate this one. So first we're going to take the antiderivative. Notice I have a sum. So when I have a sum, I can just take the antiderivative one piece at a time. So my antiderivative here, I'm going to add 1 to my exponent. So I get x to the 5th, and then I have to times that by 1 over that exponent. And I need to keep my 3. And if I simplify that, I get 3/5 x to the 5th. Okay, the other part, I need to add 1 to my exponent, so I get x to the 4th times 1 over that exponent, and I keep my 4. And I can simplify that. 4 times 1/4 is just 1, so I'm left with x to the 4th. So here's my antiderivative. Now I need to evaluate it from -1 to 1. So I'm going to do the upper bound first. I'm going to substitute in a 1. So I'm going to have 3/5 times 1 to the 5th plus 1 to the 4th. That's with substituting in my 1. And then the other side, I'm going to minus 3/5. Yes, my phone is barking at me. I'm going to plug in -1 to the 5th plus -1 to the 4th. And then I'm going to simplify that after I figure out if I need to answer this phone call. Nope, I do not. Sorry about that. Now my phone is close at hand. All right, let's simplify this. 1 to the 5th is just 1. So I'm left with 3/5 plus 1 to the 4th is 1. Minus over here, -1 to the 5th. Okay, be careful on this. When you take a negative and multiply it out 5 times, you're going to end up with a negative. So this is going to give me -1 times 3/5, which is -3/5. -1 to the 4th, when you multiply a negative number by itself 4 times, it turns positive. So that's going to be +1. And I notice here I have some common denominators, so I'm actually going to distribute this negative before I can add these all together. So I have 3/5 plus 1. If I distribute my negative, I get positive 3/5 minus 1. So notice the plus 1 and the minus 1 eliminate each other, and I'm left with 3/5 plus 3/5, which is 6/5. And that is the answer to my level 2 question. Okay, level 3. I can use substitution. So they want me to use substitution on these problems. I do want to point out on letter C, you actually don't need to use substitution on this problem. So I'm going to do it with substitution, but there is another way of doing it. You could actually distribute this and then do it like we did problem 2. But since I did say to use substitution, I'm going to go ahead and use substitution. If you already did this by distributing it and solving it like we did problem level 2, that's fine. You don't have to go back and fix it. That is quite all right. On the quiz, I'm not going to have quite so many problems, and you will sort of be forced to use substitution on it. All right, so here we go. So looking back at this one, first of all, I don't like square root symbols, so I'm going to rewrite this as 4 times parentheses 4x minus 1 to the 1/2 dx. Okay, now my u is wherever I have a higher x degree of x, so that would be the 4x minus 1. So my u is going to be 4x minus 1. My derivative of that, my du dx, is just 4. So notice I do have a 4 right here, and this is my u. So I'm going to rewrite this as my 4 is my du dx, and then in my parentheses, that's my u to the 1/2 dx. I can now cancel out my dx's. So if I rewrite this, I like to write the u part first, and then the du. So now I just need to find the antiderivative of u to the 1/2. So to do that, I add 1 to it. 1/2 plus 1 is 3/2, so I have u to the 3/2. And then I need to multiply by the reciprocal, 2 over 3. And that would be plus c, but I'm going to go ahead and substitute now in for my u. So I have 2/3 plus c. My u is 4x minus 1 to the 3/2 plus c. It's an indefinite integral, so I need to have my plus c. Okay, let me make sure I wrote that correctly. Yeah, looking good. Okay, next one. Again, I don't like square roots, so I'm going to rewrite this as x squared times x to the 3rd plus 5 to the 1/2 dx. Okay, just like on the previous one, I need to identify my u, so I look for the higher degree on my x, so my u is x cubed plus 5. My du dx is equal to 3x squared, and that's it. So do I have a 3x squared? Ooh, I have an x squared, but I don't have a 3x squared. I'm missing the 3. So if I'm missing part of the du dx, I'm going to have to put it in. So I'm going to put in a 3 here, and to counteract that, I need to multiply by its reciprocal, because 1/3 times 3 is 1, and I'm allowed to multiply by 1. All right, so now I'm going to rewrite this. This is 1/3. The 3x squared is my du dx. X cubed plus 5 is my u. And I have my dx. Now I can cancel out my dx's. So I still have my 1/3. I'm going to write the u first, because I just like to. Du. Now I can do the antiderivative. So just like I did on the previous problem, I'm going to add 1 to that exponent. So I keep my 1/3, u to the 3/2, and then I need to multiply by the reciprocal of that. And again, that's being multiplied by 1/3. So if I simplify that, I get 2/9 times u to the 3/2. I'm going to go ahead and substitute back in for my u, which is x cubed plus 5. And that's to the 3/2, and I write my plus c because it's indefinite integral. There it is. Okay, letter C. Again, I could actually distribute this and do it that way, but since the instructions asked us to use substitution, let's go ahead and use substitution. I don't have a square root, so I don't have to rewrite it. So u is going to be 4x cubed plus 6, because that has the higher degree, higher exponent. So my du dx is equal to 12x squared. I don't have a 12x squared, so I need to put in my 12. So I'm going to put my 12 here. To counteract that, I need to multiply by 1/12, because 1/12 times 12 is 1. We're allowed to multiply by 1. So this is my du dx. This is my u. So I'm going to rewrite it in terms of u. So I have 1/12 times, this is du dx, is the 12x squared. And then I have 4x cubed plus 6. That's my u. Notice it doesn't have an exponent. It does, since it doesn't have an exponent, we could say it's a 1. So let's go ahead and write that. And then I still have my dx. I can now cancel out my dx's. So I have 1/12 u to the first du, or just u. You don't have to write the exponent. But I find it handy to write the exponent, because when I take the antiderivative, I want to add 1 to that. So I'm going to keep my 1/12. I'm going to get u to the 1 plus 1 is 2. I need to multiply by the reciprocal of that, which is 1/2. which will then get multiplied by 1/12. So if I multiply that out, I get 1 over 24, and then I'm going to substitute back in my u for x cubed plus 6, the whole thing squared, and since it's an indefinite, add my plus c. Okay, so that was level 3, using substitution. And notice with a little bit extra there, you needed to be able to, when you don't find your du dx, you need to be able to compensate for that. All right, now for the hard ones. And unfortunately, these came out kind of similar. I didn't realize that when I picked these problems. They look so different, but they're not that different. Okay, so the first one, notice I have e to the sine x, so that's got to be my u. That has to be my u. So my u is going to be equal to sine x. Now du dx, it's the derivative of sine. So if you're getting confused like I do, I get confused very easily. If I want to find the derivative of sine, I'm taking the derivative. The derivative of sine is cosine, okay, as opposed to the antiderivative of sine being negative cosine. This time I want the derivative. So the derivative of sine is cosine. And lo and behold, there's my cosine. So that's my du dx. Okay, this is going to be my du dx, and this is going to be my, my u. Sine of x is going to be my u. So now I'm going to rewrite this. So 0 to pi over 2 du dx e to the u dx. I can cancel out my x's, my dx's, and I'm left with, from 0 to pi over 2, I'm left with e to the u du. So I just rearrange those. Now I'm going to take the antiderivative of e to the u, which, fortunately, is just e to the u. And for those of you who watched my previous video, this is where I made my mistake. I think it was on this one. I did not substitute back in for u. Or maybe I did that on this one. I can't remember. But anyway, I messed up somehow. So when I do this, I can't plug these in yet because I need to substitute back in for my u. So my u is sine x. So don't forget to substitute back in for the u, which I sometimes do. Okay, now we're ready to evaluate it. So now I'm going to evaluate. I'm going to, do I have enough room? I think I'm going to bring it up here a little bit. I'm going to put it here. So I'm going to have e to the sine of pi over 2. Okay, that's going to be the first one, minus e to the sine of 0. Okay, so I have, there's my evaluating with pi over 2. Here's my evaluating with x is 0. Okay, now what does this equal? Sine of pi over 2. So I need my unit circle. Pi over 2 is up here. The coordinates there is 0, 1. Sine is the y. Oops, I'm off the top. Okay, here's pi over 2 is right here. The coordinates up there is 0, 1. Cosine, sine. So sine of pi over 2 is 1. So this gives me e to the first. And then sine of 0. 0 is right here. The coordinates right there are 1, 0. Sine is the second one, so it's 0. So this would be e to the 0. Now I can simplify that. E to the first is just e. E to the 0 is 1. So my answer is e minus 1. And that's that. Let me box it since there's so much going on. Okay, next one, really similar problem because I've got that e to an exponent that's crazy hard. Okay, so this is going to be my u right here. So let me draw a line so we don't get confused. So my u is going to be equal to, actually maybe I'll put it over here. Let's use my space a little bit better. I'm not very good at using my space. All right, so I have u is equal to x cubed plus 8. So my du dx is equal to 3x squared. So do I have a 3x squared? No, so I need to put in the 3. I got the x squared, so I need a 3, so I need to counteract it by putting in a 1/3. Now I have my du dx, and I have my u. So now I can rewrite it. I now have my 1/3, still going from -2 to 0. This whole thing, 3x squared, is my du dx, and I have e to the u. The dx's cancel off, so I have 1/3 from -2 to 0 of e to the u du. I'm now going to take my antiderivative. E to the u, just like we did before, is e to the u. I can't believe I made these two so similar. So this is going to be e to the u, and again, evaluated from -2 to 0. But I got to substitute back in with my u. So it's going to be e to the u. What was u? X cubed plus 8. Evaluate from -2 to 0. So start with the upper bound, and I'm going to go up here. So start with the 0. So I'm going to have e to the 0 cubed plus 8. That's going to be my upper bound, minus the lower bound, e to the -2 cubed plus 8. Okay, 0 cubed is just 0. 0 plus 8 is 8, so I'm left with e to the 8th. And then over here, -2 times -2 times -2 is -8. This is -8. -8 plus 8 is e to the 0, which just gives me e to the 8th minus 1. E to the 8th minus 1. Oh, I forgot my 1/3. My 1/3. So I forgot my 1/3. I just looked at my answer key. I'm like, wait a minute, that's not what I got. I forgot my 1/3. So all of this is times by 1/3. All of these are times by 1/3. Doesn't matter if I put it inside or outside of the parentheses there. So all of this is times 1/3. This is times 1/3. So these are also times 1/3. 1/3 times 1 is 1/3. So minus 1/3. Eek! I did it again. This is the second time I've made this video. Why can't I just do it without making mistakes? Okay, I'm not doing it again. These have a common denominator of 3, so it's e to the 8th minus 1 over 3. So you could leave it like this, or you could write it like this. This is a little more elegant, e to the 8th minus 1 over 3. Or another way you could have written it is 1/3 times e to the 8th minus 1. That also would work. So that, or that are all equivalent ways of writing the answer. And I think that's it. Good luck tomorrow.